Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Yes and by James Sinclair, and I believe that's in reference to sort of keeping your mind open for doing things that you're not necessarily comfortable with, right? And it's basically saying, so like someone asks you if you want to do something, you say yes, and let's also do something more, maybe along the lines with what you're being asked to do. Anyways, this is by James Sinclair, and the rules, let's get to the rules. We have normal Sudoku rules apply, and all clues are standard. So we have normal Sudoku rules, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have arrows, where the sum of the digits along an arrow is equal to the digit in the connected circle. And these digits can repeat if allowed by other rules. So, for example, if this were, say, a 3 and a 3, then this digit would have to be a 6, because the digits along the arrow must sum up to the digit in the arrow's circle. And that's an example of how arrows work. We also have Renban lines, where purple lines contain a non-repeating set of consecutive digits in any order. So, for example, we could have something like, say, 5, 7, and 6 here. And this would be valid because these three digits form a set of non-repeating consecutive digits in any order. 5, 6, and 7 are all consecutive. You could not, though, have like something like 5, 8, and 6 because 5, 6, and 8 does not form a set of consecutive digits. So those are examples of how Renban lines work. We have entropic lines, where digits along orange lines. So, along orange lines, every set of 3 adjacent cells contains one low digit, which is 1 through 3, one middle digit, which is 4 through 6, and one high digit, which is 7 through 9. So that's for any 3 digits along an entropic line. So, for example, we could have something like, say, 2, 8, and 4 here. And this would be valid for this set of 3 digits, adjacent digits on the entropic line, because we have one low digit, 2, one middle digit, which is 4, and one high digit for this set of 3 unique, or 3 digits along this entropic line, which would be the 8. That's an example of how entropic lines work. And finally, we have digits in cells with a shaded circle are odd. So all 5 of these digits here are odd. And those are all the rules. If you'd like to play along, also, find more puzzles like this at artisanalsudoku.com. And that is James Sinclair's website. And if you enjoyed a puzzle like this today, you could do more puzzles that he creates at artisanalsudoku.com. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Interesting. So, each of box 2, 4, 6, and 8 has a Renban line on it and has an entropic, 3 cells from an entropic line on it and 3 cells from an arrow on it. Well, we know the minimum of 3 unique digits adding up to a single digit must be 6 through 9. Must be 6. Because if you do not, if you have the minimum, this would be 1, 2, and 3. But again, because you have an entropic line in each of these boxes, we are guaranteed one low digit here. So this cannot be 1, 2, 3 as a triplet, which means this has to be 7, 8, and 9. So that's a high digit here. Which means we have to have, and anytime you have 3 unique digits adding up to a singular one, you're guaranteed 2 low digits in that set of digits, at least. Right? Because 1, 2, 3, you have 3 digits, which are low, which are 1, 2, or 3. To add up to 7, you have 1, 2, 4, which has 2 digits from 1 through 3. 8 has 1, 2, 5, and 1, 3, 4, both of which contain 2 digits at least from 1 through 3. 9 can be 1, 2, 6, 1 through 5, or 2, 3, 4, all of which contain 2 digits from 1, 2, or 3. So that means in each of these cages, you're guaranteed to have 2 low digits and 1 middle digit. Interesting. That means we are left in each of boxes 2, 4, 6, and 8. You're guaranteed 2 lows and 1 middle on the arrow. On the entropic line, you have 1 low, 1 middle, and 1 high. And that means on the red band, what we have left are 2 high digits and 1 middle digit. And anytime you have that combination, it's always going to be 6, 7, and 8. And that's going to be the same for box 2, box 4, and box 6 and 8. Because, again, every one of them has 3 digits on an arrow, which means you're going to have 2 low digits guaranteed, and then 1 middle digit because of the entropic line. And the entropic line gives you 1 low, 1 middle, 1 high. And the red band line left over is 2 high digits and 1 low. And to have two high digits and 1 low to be consecutive, it has to be 6, 7, 8. And since this has to be then 6, 7, 8. So we have 6 and 8 here, 6 and 8 here. This is guaranteed to be 7. 6 and 8 here, 6 and 8 here, with this guaranteed to be 7. So this is 6, 7, and 8 here, 6, 7, and 8 here. And the entropic line, the high digits always have to be 9. So this cannot be 9 here. And we cannot have a 9 here. Because we have a guaranteed 9 in one of these entropic digits. Because that's the only high digit remaining in those boxes. And this, then, can only be the sum of, again, 2 low digits and a middle digit, and then another digit here. Well, that minimum is 1, 2, 4 plus 1, which is adding up to 8. So this is 8 here. This must be 1, 2, and 4 here. That leaves 3, 5, and 9 remaining in the entropic set, and this being 1 here. 8 eliminates 8 here, so it's 7, which means this must be a 1, 2, 4 triplet. And this must be odd, so this would have to be 1. That means this is also 3, 5, and 9 remaining in box 4. These are 3, 5, and 9, which are all odd. We have 2 more odds in column 7, so this is 1 and 7. This can't be 7 because of 7 in the row. So that makes this 1, which makes that 7. The remaining digits in column 7 are all even. So it's 2, 4, 6, 8. No 8 here because of 8 in the box. No 6 here because of the 6, 7, 8 triplet in the row. This can't be 6 or 8 for the same reason. We have a 2, 4 pair in column 7, which eliminates 2 and 4 in the rest of the column. So this can't be 2 or 4. It's 6. This can't be 2, 4, or 6. It's 8. 7 and 1 or 2 has to add up to a single digit. This can't be 1 because of 1 in the row. So 7 and 2 add up to 9. That eliminates 9 in the rest of the row. 7 eliminates 7 in the rest of the row. So these must add up to 9. We have 1, 8, 2, 7, 3, 6, and 4, 5 as possibilities. No 1, 8 here means this can't be 1 or 8. No 7 here means this can't be 2. No 2 or 1 here means this can't be 7 or 8. No 3 or 5 here means this can't be 4 or 6 correspondingly. No 3 or 5 here means this can't be 4 or 6 correspondingly. This can't be 8. This can't be 6 or 7. We are guaranteed a 1 here. No 6, it could be 1, 3, 5. That's possible. No 1 here because of 1 in the row, so this can't be 8. Okay. This is 3, 5, 7. 1 eliminates 1 here. This can't be 2 because of 2 in the row, so this is 4. That eliminates 4 in the rest of the box. These are both even. Where is 7 in column 3? Cannot be here because of 7 in the box. Can't be here because of the red band. Can't be here because of 7 in the row. Can't be here because of 7 in the row. So 7 has to be here, which means this is also 1, 2, 4 as a triplet. That leaves this room again as 3, 5, 9 for the remaining digits in this row or box. This can't be 7, it can't be 6, it can't be 9 because of the 3, 5, 9 triplet here. That leaves us as 8. So this is either 1, 2, 5 or 1, 3, 4 here. We're not sure which. So this is 2, 5, 9 or 3, 4, 9 here. No 2 here because of 2 in the column. Where is 6 in row 3? Cannot be here because of 6 in the box. Can't be here because of 6 in the 6, 7, 8 triplet in the box. 7 eliminates 7 there. So it must be one of these two, but this can't be 6 because of the 6, 7, 8 triplet in the column. So that leaves this as a 6. And 6 plus 3 adds up to 9. So this can no longer be 3 here. No 6 there then. It's 2 and 7 or 4 and 5 here. 3 eliminates 3 in the rest of the row. We now have a 5, 9 pair in row 4. Okay, this is a Renband here. We don't have 2 or 3 available, so 1 cannot be on here. So where is 1 in this box? It has to be one of these 2. We also can't have 2 or 3, so it could be 4, 5, 6. It cannot be 5, 6, 7. That would eliminate all possibilities for this cell there. So it's 4, 5, 6. No 5, 6, 7, but it could be 6, 7, 8. So we're guaranteed a 6 has to be here. And this is guaranteed to have 4, 5, or 7 on it. Which means 5 or 7 cannot appear in the rest of the box because we have a 1, 5, 7 guaranteed here and a 5, 7 guaranteed here. Which means this must be 1 with 4 or 8 as possibilities. Again, we can't have 5 here because of the 5, 9 pair in the row. We can't have 5 here because of the 3, 5 pair in the row. Remaining digits of column 3. We have 1, 2, and 4 remaining. Remaining digits of row 7. We have 1, 2, 4, and 6 remaining. And these cannot be 1, 2, or 4 because of the 1, 2, 4 triplets in their columns. We're missing 8, too. And this can't be 8. This can't be 8 because of a 6, 7, 8 triplet in the column. So 8 has to be here. This is 6. And that leaves this as 2 or 4, because this can't be 6 because of the 6, 7, 8 triplet in the column. This 2, 4 pair eliminates 2, 4 in the rest of the box, so this can't be 2 or 4. It's 1. That eliminates 1 here. So this becomes a 2, 4 pair in row 1, which eliminates 2, 4 in the rest of the row. That leaves 1, 3, 5, and 9 remaining. And 1 cannot be in the rest of box, this upper right-hand box, because of 1 in the box. So 1 has to be one of these. Cannot be here because of 1 in the column. So 1 has to be here, which is a Renban only with 2 and 3. That eliminates 2 and 3 in the rest of the box. So this can't be 2, it's 4. That means this can't be 4, it's 2. 2 and 7 add up to 9. 2 eliminates 2 here, so it's 4. 2 and 4 as a pair eliminates 2 here, so it's 3, which makes this 2. Therefore, this cannot be 1, 3, and 4 here. It's 1, 2, and 5, which eliminates 1, 2, 5 in the rest of the box. So this is now 3, 4, and 9. That eliminates 3, 4, and 9 in the rest of the row, which leaves just a 5 remaining in row 3. 5 eliminates 5 in the rest of the box. This is a 3, 9 pair, which eliminates 3, 9 in the rest of the row, so this can't be 3 or 9. It's 5. That remains. That means a 9 remains in this upper left-hand box. 9 is only consecutive with 8, but we already have an 8 in this box, so this can't be 9 there. It's 3. 4 eliminates 4 there, so it's 2, which makes this 4. 3 is consecutive with 2 or 4, but this can't be 2 because of 2 in the box, so it's 4. 3 eliminates 3 there, so it's 9. That leaves this digit as a 7. Okay. 7 eliminates 7 here. Where's the 7 remaining in row 1? It has to be here. This cannot be 5, 6, 6, 7, 8 anymore. So this must be 4, 5, 6. And 5 cannot be either of these cells, so this is a 4, 6 pair, which eliminates 4, 6 in the rest of the box and column. So no 4 here, no 4 here, no 6 here, so this is 8, which makes this 6. 6 eliminates 6 here, so it's 8 and 6, and this 4, 6 pair forces this to be a 5. This cannot be 4 anymore, it's 1 and 8. 8 eliminates 8 here, so this is 1, which makes this 8. 1 eliminates 1 here, so it's 2 and 1. 2 eliminates 2 here, so it's 4 and 2. 4 eliminates 4 here, so it's 6 and 4. 6 eliminates 6 here, so it's 8, which eliminates 8 in the rest of the row. 7 eliminates 7 here, so it's 6, which makes this 8 and 6. 6 eliminates 6 there, so it's 7. No more 5 here, no more 5 there. No more. 2 eliminates 2 here, so that's 1. So this can't be 1 here. 1 eliminates 1 there, so it's 5. No more 1 or 5 there. It's 2, which makes this 1. 2 eliminates 2 there, so it's 4 and 2. 3 and 4 eliminate 3 and 4 here, so it's 9, which makes that 3, which makes that 4. 3 and 9 eliminate 3 and 9 here, so it's 5, which makes this 3, which makes that 9 there. We are losing a high digit in these 3 digits here, so this must be high here for this set of 3 digits, so that's 9, which makes this 3. That makes that 5, which makes that 3 there, which makes that 5 there, and that's 9 there. So these set of 3 digits has a low, middle, high. These set of 3 digits has a low, middle, high. So do these, and so do these. And the rest is just normal Sudoku. So remaining digits, actually, let's just do ones. That's 9 ones. We have all the not ones. We have 8 twos, so the remaining 2 has to be here. Oops, not a color. Threes. We have 7 threes, but the 3 remaining in column 9 has to be there. That gives us 8 threes, and we know where the last 3 has to be. It's there. 4, that's 3 in the corner. We celebrate because we're almost done. We have 9 fours, 5s. We have 5 in column 1 can only be here. That gives us 8 fives, so the last 5 has to be there. 6s. We have 8 6s. The last 6 is there. 7, we have 9 sevens. 8, we have 9 eights, and the remaining digits are 9. So we have 9 here and 9 there. And that's the solution. Yeah, pretty straightforward. That was very interesting, actually. The restrictions in... Oh, I didn't explain what box 2, 4, 6, and 8 are. But anyways. Well, okay. So how we normally number boxes is by typical Western reading notation, which is from left to right and top to bottom. And so this would be considered box 1 here. We have box 2 here, box 3 here, 4, 5, and 6, 7, 8, and 9. So that's why I was highlighting boxes 2, 4, 6, and 8, because they had a similar pattern, right? Because you're guaranteed on the arrows, each of the arrows, you're guaranteed 2 digits that are guaranteed to be low, at least. And because of the entropic line, which has 3 cells, all consecutive in the same box as the arrows, one of them has to be low. So we cannot have 3 lows here. Therefore, we're forced to have 2 lows and 1 medium on these arrows, because you can never have a high digit adding up to a single digit with 2 other digits, right? 7 at minimum adds up with 1 and 2 to add up to 10, which is not a digit. So that was the same case for boxes 2, 4, 6, and 8. And then because of that, we knew the renban, which has to have consecutive digits. We already have a high, we have 2 mediums, and all 3 lows accounted for. So that leaves us 2 highs and 1 medium as the renban. And to form a consecutive set, it's always going to be 6, 7, and 8. And so we had 6, 7, 8 for that. And therefore, the high digit always had to have 9. And just everything flowed from that. So it was pretty straightforward. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.